We're going to cover pages 48 and 49 of the workbook. This deals primarily with solids and also changing dimensions and doing things with scale factor. Let's get started with problem 1. So for this first page, page 48, you're going to be using your formula sheet a lot, which I'll be going back and forth to. So problem 1 says the base of a right rectangular prism is 12 centimeters by 8 centimeters and the height is 5 centimeters. Find its surface area. Well, a right rectangular prism is this shape right here. We're asked to find the surface area, so that's what we're going to use. So we have surface area is equal to 2LW plus 2LH plus 2WH. And all I need to do is find L, W, and H. So I can call L 12, W 8, and H is 5. So remember, whenever it says the base is 12 and 8, that's your length and your width. So I plug those in. 2 times 12 times 8 plus 2 times 12 times 5 plus 2 times 8 times 5. This is all something you put in your calculator, and whenever you do that, you're going to get your final answer, which is going to be 392 centimeters squared. Let's move on to number 2. It says the slant height of a regular pentagonal pyramid. So this one might be a little bit hard because we haven't talked about pentagonal pyramids, but we have talked about pyramids. That's the shape of a pyramid. Let's keep reading the problem though. Is 8 centimeters. So the slant height is 8 centimeters, so you know L is 8. The length of each side of the base is 4 centimeters. Find the lateral area. So the formula for lateral area was 1/2 LP. So again, you find the shape, you find the formula, and you just plug it in. So we have 1/2 LP. I already have L, I have to find P. Remember, P is the perimeter. So if each side is 4 and it's a pentagon, that means 4 times 5 is going to be my perimeter, which is 20. So whenever I substitute everything, it's going to be 1/2 times 8 times 20. So you plug that straight into your calculator, and you get the correct answer of D, 80 centimeters squared. Let's take a look at number 3. It says a sphere with radius of 6 centimeters is inscribed in a cube. So remember, inscribed means it's like stuck in there. So you might think about putting a basketball in a box or something like that. Find the area, or sorry, find the volume of the cube. So let's go back to our formula sheet again. I'm going to clear the ink, that way we'll be able to see more. A cube would be this one right here. Remember, a cube, and we need volume, so that's why I circled volume also. The length, the width, and the height of a cube are all the same. So if I have a box, which is kind of around a pyramid, and if I have a radius that is 6 centimeters, that means that the whole width, length, and height is all going to be 12. If the radius is 6, the whole thing needs to be 12. So now I'm ready to solve the problem. So volume is equal to length times width times height, and that is just 12 times 12 times 12, which will get you the correct answer of C, 1,728 centimeters cubed. All right, let's take a look at number 4. It says you are using the rectangular gift box shown below to wrap a present. How many square inches of wrapping paper would you need to cover the box? So a hint here is square inches of wrapping paper. So remember, we told you that surface area was just like wrapping a present. Volume was like filling something up. So I always use the example that surface area would be like the amount of cardboard on a milk carton, where volume would be the amount of milk that's in the milk cart. That's the difference between surface area and volume. So what we're going to use is surface area. So let me clear the ink again. Our shape is a rectangular prism, and this is the formula for surface area. So, again, I'll copy the formula down. And right here I have a length of 9, a width of 9, and a height of 3. So what I'm going to do is just substitute all of those values in. So again, this is another one where you just use your calculator. You type in the right buttons, and you're going to get D as the correct answer. Question 5 says the cargo space of a truck is 2.44 meters wide, 2.76 meters high, and 8.20 meters long. How many cubic meters of cargo space does the truck have? A good way to solve this problem is to look at cubic meters. It doesn't say solve for the volume. It says how many cubic meters. If we want to solve for cubic meters, that means we're going to have to use volume. So once again, I have the same shape, but I'm not solving for surface area this time. I'm solving for volume. So the volume is equal to the length times the width times the height. And we just have all of those numbers. So 2.44 times 2.76 times 8.20. Once again, we plug it in our calculators and we get the correct answer of B. So question 6 was one on here that I didn't get the exact answer. I got something very similar. It says a can is half full of liquid. So you have to think about what shape a can is. So in my world, a can is a cylinder. So it says find the volume of the liquid of the can if the can has those measurements. So the can is half full, so that means I'm going to take the volume of the can, and since it's half full, I'm going to divide it by 2. So I'm going to have pi r squared h divided by 2. So for the diameter, given the diameter, I need to find the radius. That's going to be 1.25, and h is going to be 5. It's going to be pi times 1.25 squared times 5 over 2. And whenever I did that, I got a number that was very close to 12.23 inches squared. Number 7 is probably the trickiest problem on this section. It says the water level in a rectangular prism. So once again, we're using this rectangular prism. So I already have it circled in blue. So I'll just erase the cylinder to show you the blue one that I have. Is 40 by 20 by 12. So I want to find the volume of this right here. So that's the formula, length times width times height, and I get 9,600. Remember, that's centimeters cubed. It says a rock is submerged in the tank, raises the water level to 0.4 centimeters. So that means the new height is equal to 12 plus 0.4, which is 12.4. So I can find the volume of this tank by doing 40 times 20 times 12.4. And whenever I do that, I get 9920. I'm asked to find the volume of the rock. So all I simply need to do is subtract 9,600, and I get my final answer of 320 centimeters cubed. So let's go on to the other page. The other page we won't be using our formula sheet for. This is page 49. This uses a different standard with proportional reasoning, and we have to see how changes in dimension work. So let's start off with number 1. Number 1, we're asked to solve for x. So what I need to do is take one triangle, the lengths there, which are x and 6, and I need to put them over the values of the other triangle. Here's where we run into problems. Everybody sees the 10 goes underneath x, but how big is this side here? It's 6 plus 6, which is 12. Once we have it set up, it's a pretty easy solve. We get 12x is equal to 60, so x is going to be equal to 5. Let's keep going with problem 2. Again, we have similar triangles. We know these are similar because we have two pairs of corresponding angles, and it'll be similar by angle-angle similarity. If you take a look, I think if it's section G5, you'll see a different examples on similar and congruent triangles. So what I have here is 5 and 4 for the top one, and this side is going to be 5 plus x, and this side is going to be 14. So I'm going to put 5 plus x and 14. So that's the whole triangle. Whenever I cross multiply this, I'm going to get 70 is equal to 20 plus 4x. Whenever I solve for it, I will get a final answer of 12.5. Numbers 3 and 4 are a little bit tricky. The reason why is because we don't have the same units. So let's take a look at this. It says we have a background story in the first sentence that we don't need anything to solve with. We start in the second sentence. It says the ear of corn is 32 feet long and has a radius of 12 feet. What is the scale factor between the giant ear of corn and a similar real ear of corn that is 14 inches long? So in order to find the scale factor, we were saying it was A over B. So we're going to take the giant ear of corn, we're going to put that on top. The problem is we need to get it in the same dimension. So we have feet and we have inches. So 32 feet is equal to 32 times 12 inches, which is 384. So that means I'm going to have 384 over 14. And that'll simplify to 192 over 7. So remember, if you're unsure how to do that in the calculator, you do alpha y equals, enter, and we type in 384 over 14. And it'll give us our final answer, 192 over 7. So in order to solve number 4, we're told each kernel of the ear of corn in number 3 has a volume of 231 cubic inches. So since we have volume, we know we're going to have a cubed over b cubed. Remember, volume's in inches cubed, so that's going to help us solve this problem. So I have a over b. A over b is equal to 192 over 7. So a cubed over b cubed is going to equal 192 cubed over 7 cubed. And we're told that on the bigger ear, we have 231. So if I want to solve this, it's kind of tricky. I'm going to have 192 cubed x. I didn't cube it right away because I'm going to get a very large number. And I get 231 times 7 cubed. Remember, I'm just multiplying here, so I'm going to divide both sides by 192 cubed. And whenever I do all of that, I'm just going to put it in my calculator to get the right answer. So again, alpha y equals enter. 231 times 7. Remember, I use this caret button here. 7 to the third, and I have to hit over and close my parentheses, and then I have 192 to the third power. So I get 0.011, which is answer A. So please watch the other videos, and good luck on your SOL.